This is an application for ANOVA with blocks. You have this Excel sheet on Blackboard. I did a little bit of changes, so you might not have exactly the same thing, but you do have the data on Blackboard. So the setup that we have is we have three groups, and we're giving different doses of certain drug. So 5 milligram, 10 milligram, 20 milligram. And however, we have the same people that are being measured every time. So عندنا Jad, Marcella, Ad, Malik, Jihan, Samar. And we're interested in knowing if our outcome, which I don't know, what could be diastolic blood pressure, could be maybe fasting blood sugar, I don't know what it is, if it's different for different doses. Okay. So what I did is I've calculated the average for every group, and I've calculated the standard deviation for every group. I've also calculated the average for every person, and I've calculated the standard deviation for every person. And I finished with the average of the entire data set and the standard deviation of the entire data set. Okay. Now, how do you go about testing the hypothesis? I will show what is the research question. The research question is there evidence suggesting that the average, let's say fasting blood sugar, is there evidence suggesting that the fasting blood sugar is different between the three doses of the drug? Step number one is setting your null hypothesis. Mean fasting blood sugar for 5 milligram dose equal mean fasting blood sugar for the 10 milligram equal the 20 milligram. The alternative hypothesis, they're not equal. We assume the null is true. We set alpha at 5%. And then step number three, you need to calculate your test. Which test do we use? You ask the famous three questions. How many groups do we have? What is the nature of our outcome? And is the data dependent or independent? We have three groups. Okay, and obviously the outcome is numerical, and since it's same people measured every time, it's dependent, and therefore it's the ANOVA with blocks. So what I'm going to do first is I'm going to calculate the sum of square total. ليش? This is the advantage of having the standard deviation for the entire data set. If you have the standard deviation of the entire data set, you use the following formula, which is sum of square total is nothing but the standard deviation total, you square and you multiply by the degrees of freedom, يعني n minus 1. Okay, so let's go back to our formula. So right on, I'm going to do the between and the within, though it's not the correct thing to do, but I'm going to do it here just to show you that they add up. Okay, so for the sum of square total, I take the standard deviation total, you square that and you multiply it by n minus 1. So I had three groups by 6 individual, that's 18 minus 1, that's 17. Okay, so our total sum of square is 1345.78. When I want to fill this table, this is the table that I want to fill. The total is the total, so nothing changes for the total. Okay, next I'm going to do the within. Again, I'm not going to need the within for filling my table, but I'm just going to do it so that I can show you that the within get be split between blocks and residual. Okay, so the within, remember how we do the within? You're going to take the sum of square within every group. So since you have the standard deviation of every group, the sum of square within is nothing but the standard deviation of those 5 milligram. You square and you multiply it by the number in the 5 milligram minus 1 plus the standard deviation for the 10 milligram, and then you multiply it by the number in the 10 milligram minus 1 plus till you finish the last one. Okay, so you remember the formula. So I'm going to do it one at a time and then I'm going to add them up. So it's nothing but the standard deviation in this group. You square that and you multiply. I hope you can see the formula right here, okay? And you multiply by, well, how many observations? I have 6 minus 1 is 5. So that's for the 5 milligram. I can just use the drag formula because actually I have 5 in every group, so that's going to be easy. And then I'm going to add these three together to get me the sum of square within. So you add these three together. So the sum of square within is 655. I'm not going to plug it in the table because I'm not going to use it. Okay. but I'll use it in a minute. Okay, so let's see. The between, how did we used to do the between? Well, if you remember, the between is the average minus the average of the averages, you square. So again, I'm gonna go back and forth just to remind you of the formula. So the sum of square between يلي هي is exactly the same as treatment, is the average of group A minus the average of the averages, you square, you multiply by the number of observation in A, and you do that for every group. All right, so let's go back here. I'm going to use the space, so not to lose the 655, I'm just going to copy it and paste it as number, بطلت formula. So now I'm going to delete this to be able to calculate the between. So the between is you take this average minus this average, and we're going to put dollar signs to fix it. Okay, you square that difference and you multiply by 6. Okay, so we're going to do that for every group. You can see why we get a small number here, because the average here is so close to the average of the averages. Okay, and then for the between, you're just going to add these values right here. Okay, 690.1.778, that's the between. Okay, and we're done. Again, I'm just gonna copy and paste so that we don't lose it. Just a verification, if you were to take the between to add it to the within, you should get exactly what we had for the total. So it's working perfectly fine. Okay, let's come to this table so that we actually do the one we're interested in. The treatment is nothing but the between. Hala, for the blocks and the residual, I have to do some calculation. Okay, so how do I get the blocks? Well, to get the blocks, you're going to do the exact same thing. Let me just show you the formula again حتى هيك بنكون complete. So the sum of square blocks is the average of block 1 minus the average of the averages, you square, and then you multiply it by the number that are in block 1. But the number in block 1 is nothing but the number of groups, yani k. And you do that for every one of them. So I take the average of Jad minus the average of the averages. I'm going to put dollar signs so that I don't lose it. You square that and you multiply by 3 because I have three observations for Jad. Okay, you do that for all of them. Okay, and then when you come and you add these, that's your sum of square block, 482.44. And to get the residual, what you do is يا اما فيكم تاخدوا this total minus these two together, or you can take the within minus the block. هلا انا عم بكتبها غلط لاقدر صلحها. It's not E, it's F. So that's your residual sum of squares. And again, if you were to add these three values together, you will get exactly what we had at the beginning, اللي هو total. Okay, now it's the degrees of freedom, which is not difficult. For treatment is the number of treatment minus 1. I have 3 groups minus 1 is 2. For the blocks is number of blocks minus 1. I have 6 minus 1 is 5. For residual, you multiply the top 2 together, so 2 times 5 is 10. And for the last is 12 minus 1. 3 times 6. 3 times 6 is it's 18 minus 1 is 17. Yeah, okay, 17. And notice that these two together are 15. إذا كنا عم نعمل degrees of freedom of within, كنا قلنا ال 18 minus the 3 groups بيطلع معنا 15 اللي هن هول التو مع بعضهم. And now we just divide. You take the sum of squares and you divide it by the degrees of freedom. And you do the same for all of them. And for the f that we are interested, we're going to take the mean sum of square treatment. We divide by the residual. And this is our f calculated while the f observed. This needs to be compared to the f critical. F critical, we get it from the table for degrees of freedom 2 for the numerator, 10 for the denominator. So 2 for numerator, 10 for denominator, that's 4.1. 4.1. So this is my F calculated. 4.1 is my F critical. So let me write up here F critical. Okay. My F calculated is bigger than the F critical. Automatically, this means that my p-value is less than alpha. The alpha we're using here is 0.05. So p-value less than alpha. This is step number 4. 4 and 5, I guess. Step number 6, we're going to reject the null hypothesis. And step number 7, we're going to conclude that there's evidence suggesting that there's differences between the fasting blood sugar at 5 milligram, 10 milligram, and 20 milligram. بما أنه 5 milligram is producing the lowest average and the 20 milligram is producing the highest average, you can add to your conclusion that we can conclude that this is lower than that. Okay, I'm going to add one more question. Let's suppose that our conclusion was wrong. Then what have we achieved? Okay, so this is just to take you back to the famous 2x2 table that has the error, etc. Okay, so you've seen me doing this multiple times. This is reality. Okay, and this is what the test tells you to do. So the reality, either the null is correct or the null is false. The test either tells you to fail to reject or to reject. And this is the 1 minus alpha. This is the type 1 error, also called alpha. This is the type 2 error, also called beta. And this is power, also called the 1 minus beta. Okay, in our case we have rejected, and therefore if I say that by rejecting we made a wrong conclusion, it has to be a type 1 error, which means that in reality there was no differences between the groups. However, we declared that there is difference and we made a mistake. A follow-up on this question: هل يا ترى increasing sample size would help me fix the error? The answer is no. Only when you made a type 2 error does increasing sample size help you. Okay, if you made the type 1 error, increasing sample size will not help you. What you have to do is redo the study. Okay, finally, one last thing about when we reject the null hypothesis, again, remember that you declare that the differences observed are statistically significant. Okay, that's it.